Hi, Seekings. So this is section 1, part 2. You asked for additional examples our last class on Wednesday, so here we are. This is linear equations and linear inequalities. Like I said, it's a continuation, so I didn't include the essential questions. So this is example 1, part B. So I rolled the dice and I got the points 2/3, -3/5, and -3/2, +2. I've labeled them x1, y1, x2, y2. In the directions, the first thing we have to do is find the slope. So here I've written the formula for the slope. And you can see that I put in y2 minus y1, which happens, so this is the minus sign and that's a negative point. And then x2, which is -3/2, minus the x1, which is +2/3. So I changed the sign and I changed the 2 into 10/5 because I am adding fractions to get 13/5. Then in the denominator, because I'm subtracting, I needed common denominators and I wrote that out for you. So I noticed between 2 and 3, the common denominator is 6. So this first term, -3/2, I multiply by 1 or 3/3. And the second term, -2/3, I multiply by 1, which is 2/2, in order to get -9/6 and -4/6. So I bring the 13/5 into the numerator, and combining these two fractions in the denominator, I get -13/6. So notice when I have a fraction over a fraction, that means I'm dividing. So 13/5 divided by -13/6 is the same as 13/5 multiplied by the reciprocal, which is -6/13. I notice when I can cross multiply here, I get negative, or I can simplify the numerator and the denominator to get -6/5. So the next bit of instructions asked us to determine if the line falls or rises or is horizontal or vertical. And because I have a negative slope, I know that the line falls. So after that, we had to come up with the 3 equations of the line. So this is point slope form, and this is the formula for it. I chose the point -3/2 2 because it had the least amount of fractions. So y minus 2 equals -6/5, that's our slope, times the quantity x minus -3/2. So you could use this answer. I would not mark that wrong on a test or a quiz. Or you can simplify this double negative to make it a positive, and that would be right as well. So from here, to find slope-intercept form, notice I have to move this -2 over, and I have to distribute the slope. So I've done that here. I've got -6/5 times x, and then -6/5 times +3/2. I simplified that. This 2 dividing into that 6 gives me 3. 3 times 3 is 9, and then 5 times the 1 that's left over from the 2 is just 5. So when I move this to the right-hand side, I have to change the sign. And I found a common denominator to be 5, and 10/5 is, of course, 2. So when I add these two terms together to get the y-intercept, I get +1/5, and the slope is what it is before. So that's our answer for slope-intercept form. And then to get that into standard form, remember, I'm going for ax plus by equals c, and we don't want any fractions, so we'll have to clear those. So the first thing I did was I added 6/5 x to the left side, and that got me 6/5 x plus y equals 1/5. I notice I've got a 5 in the denominator here and denominator here, so I'm going to multiply the entire equation by 5, which is totally legal. You can do that. So, and mathematicians use brackets for that. So 5 times 6/5 x gives me 6x, 5 times y is 5y, and 5 times 1/5 is 1. So that's my standard form of the equation. Next, the directions asked me to find the x-intercept, and the definition of the x-intercept is that y equals 0. So I've used standard form here, and when I plug in 0 for y, I get 6x equals 1, and when I divide by the coefficient, I get x equals 1/6, and I want to write that as a point because we have stipulated that y equals 0, and that's how we tell people that this is the x-intercept. In order to find the y-intercept, it is true that the x value, the x-coordinate has to be 0, but we've already found that up here. So you can use a similar procedure, only plugging in the 0 for the x, but this, even if we did that, we would still get the value 1/5. So from there, the next thing we have to do is graph the equation. So, trusty graph paper. I'm going to graph this form, slope-intercept form. I'll graph slope-intercept form because I think it's the one that's easiest to graph from. And I think I'm just going to count by ones, even though I know our original points, we also have to plot those, and they're in fractions. It's pretty nasty. Okay, so 1/5 is going to be pretty close here. It's just 20% of the way of the distance between 0 and 1. And then -6/5. So this would be -1, 2, 3, 4, 5, 6. Am I still on the screen? I'm not on the screen at all. What a delight. Let's try that again. So I counted by 1 on both axes, and 1/5 is just 20% of the distance between the x-axis and 1 on my y-axis. And then going down 6, so 1, 2, 3, 4, 5, 6. And then over 5 to the right. 1, 2, 3, 4, 5. So that should be something around here. Now, I'm not being as precise as I could be. If I was counting by fifths, that would be even better, but I think we stand a fair chance of this. Okay, so this is our line, and it falls as we predicted in the first step. Now we also have to graph our original points, which up here are 2/3. So 2/3, 1/3, 2/3, and then down 3/5. So that's like 60%. So that's right around here. So that seems totally reasonable. So 2/3, and then down 3/5. So that's about right here. So that makes me feel like we've done everything right with our line. And then -3/2 is -1.5 and up 2. Oh yeah, that's perfect. Okay. So I would turn this assignment in and feel pretty good about this quiz problem or test problem. So that's our graph. And then it also asked us to state the domain and the range. So this being our graph, the secret about lines, domain. So the domain goes from -infinity to +infinity, and parentheses on both sides. That's important. Please parentheses around infinities, -infinity to +infinity. And the reason for that, the parentheses, is because we can't include, we can only approach infinity or -infinity. And the other reason, lines are always going to have this domain and range because they go on and on forever in both directions. Now the domain is talking specifically about the horizontal, and the range is talking specifically about the vertical. But whatever, oh, I shouldn't say that. That's not true for relations. Or if it was horizontal. Okay, so a line will have at least one of these. If it's a line with a slope that isn't 0 or isn't a vertical line, then both of them will be that. Oh, mathematics. Okay. All right, and so a second example of our other problem. This way. This would be example 2b. So again, if it's all right with you, I'm not going to write down the directions again because I don't want to take our time with that. So let's say we've got these points. So 1, -1/4. And our second point is 1,5. So the domain here, is going to be from negative infinity to positive 1 with a bracket, and the range goes from negative infinity to positive infinity, parentheses on both sides, because of course we've determined that. So I've asked you to come up with a mathematical equation for this and also to graph it. If you have no idea how to come up with a mathematical equation, then I suggest that you start with drawing a picture. So here's my coordinate plane. And these numbers are pretty reasonable, so not terrible. Am I just going by 1 again? Yeah, why not? So we'll say 2, 4, 2, 4, negative 2, negative 4, negative 2, negative 4. Okay, so we've got a point at 1, negative 1/4, so right around here. And we also have a point at 1, 5. So that feels like a vertical line to me. Like if I had to connect these 2 points, there's really no way I can avoid it being vertical line. Now I notice the domain goes from negative infinity up to and including, the bracket means and including 1. So that tells me this is not going to be a dashed line, this is going to be a solid line. So here's my solid line. And I can also tell that it's going to be everything to the left of the line. So this is really what I have going on, right? The shading is over here, right? Okay, so that's my graph. And now what's the equation or inequality for this picture? Well, we're gonna say X, because that's what we're talking about, is less than or equal to positive 1. That's the inequality for this particular line and its domain. Okay, so hopefully that has answered some questions and we're feeling better about that. Tomorrow in class we will go over some more examples if we need them. We'll do some practice problems. Hopefully we're feeling confident for that. And then maybe we'll approach some more notes. Okay, I'll see you then.